Good day everyone! You are again watching a fun and interactive video about grade 9 mathematics. Before we start, please ready your modules, your pen, and also your notebook. Without further ado, let us now start. Our topic for this video is all about solving quadratic inequalities. Here are the things to remember in solving quadratic inequalities. If the given quadratic inequality is less than or greater than, we will use an open circle to mark points corresponding to the roots of the equality, which means that that particular point is not included to the interval or in the solution. And if the quadratic inequality that is given is less than or equal or greater than or equal, we will use a closed circle to mark points corresponding to the roots of the inequality, which means that that particular point is included. And next, a closed interval means that the boundary points are included, and the notation for a closed interval uses a square brackets. And an open interval means boundary points are not included, and the notation for a closed interval uses a parenthesis. And we have here the half open or half closed interval. We'll have one square bracket and one parenthesis. To solve quadratic inequality, find the roots of its corresponding equality. Then, the points corresponding to the roots of the equality, when plotted on the number line, it separates the line into 2 or 3 intervals. And an interval is part of the solution of inequality if a number in that interval makes the inequality true. Here's an illustrative example. Number 1. Find the solution set of x squared minus x minus 6 is less than 0. So the first thing that we need to do is change the inequality x squared minus x minus 6 is less than 0 into equality. And we will have x squared minus x minus 6 that is equal to 0 to solve for x. And here's the given. The first thing that we need to do is to factor out that particular equation. And we will have x plus 2 multiplied by x minus 3 that's equal to 0. And then by applying the zero product property, we will have x plus 2 equals 0 and x minus 3 equals 0. And then transpose the constant and we will have x plus 2 is equal to 0 and x minus 3 is equal to 0, and the roots are, or the value of x is equal to negative 2 and x is equal to 3. Now that we know the value of x, we will now plot the points corresponding to negative 2 and 3 on the number line. Since the inequality is less than, we will plot the corresponding points by using an open circle. Then, identify the 3 intervals. The first interval is from negative infinity to negative 2, and negative 2 is not included. And the second interval is negative 2 to 3, and negative 2 and 3 is not included. And the third interval is from 3 up to positive infinity, and 3 is not included. And since we know the intervals, let us now determine or get some testing points in those intervals. Let us first get some testing point from this interval, negative infinity up to negative 2, but negative 2 is not included. In here, I want negative 4 as my testing point, but negative 4 is not the only point that or only number that we can use as a testing point. We can use any number from negative infinity up to negative 2, but negative 2 is not included. And here, I choose negative 4. So let us substitute negative 4 to the x, and we will have the quantity of negative 4 squared minus negative 4 minus 6 is less than 0. Then we have 16 plus 4 minus 6 is less than 0. Then 14 is less than 0. Do you agree that 14 is less than 0? Of course not. Therefore, it is false. Then, how about the second interval? From negative 2 up to 3, but negative 2 and 3 is not included. I want my testing value is 1. So let us substitute 1 to the x. We have 1 squared minus 1 minus 6 is less than 0. Then we will have 1 minus 1 minus 6 is less than 0. And negative 6 is less than 0. Do you agree that negative 6 is less than 0? Of course. Therefore, this is true. Now how about the third interval, which is from 3 up to positive infinity, but 3 is not included. So I want my testing value or testing point to be 6. And we will substitute 6 to the x. And we will have 6 squared minus 6 is less than 0. And 36 minus 6 is less than 0. And 24 is less than 0. Do you agree that 24 is less than 0? No. Therefore, it is false. Therefore, the inequality is true for any value of x in the interval negative 2 to 3, and in this interval, we do not include negative 2 and 3. Therefore, the solution is from negative 2 to 3, but negative 2 and 3 is not included. And we use parentheses. We use parentheses because negative 2 and 3 is not included. Now, second example. Find the solution set of x squared minus 2x minus 8 is greater than or equal to 0. The first thing that we need to do is change the inequality x squared minus 2x minus 8 greater than or equal to 0 into equality. And we will have x squared minus 2x minus 8 that is equal to 0 to solve for x. And let us factor out. We will have x minus 4 multiplied by x plus 2. That is equal to 0. Then by using the zero product property, we will have x minus 4 equals to 0 and x minus 4 equal to 0. Let us transpose the constant and we will have the value of x that is 4. How about the second factor? We will have x plus 2 is equal to 0 and the value of x is negative 2. Now, let us plot the points in the number line. The negative 2 and 4. Since our inequality is greater than or equal, we will use the closed or shaded circle. That means that negative 2 and 4 is included. Now, identify the three intervals. The first interval is from negative infinity up to negative 2. Since negative 2 is included in that solution, we will use a bracket. And the second interval is from negative 2 up to 4. Since negative 2 and 4 are included, we will use also a bracket. And the third interval is from 4 up to positive infinity. And we will use also a bracket. Take note that since we don't know the end point of positive infinity or the end point of negative infinity, that's why we use a parenthesis. We now know the intervals. Let us now determine some testing points. In the first interval, from negative infinity up to negative 2 and negative 2 is included, I want my testing point to be negative 3. And you can also use some testing points that is from negative infinity up to negative 2 and negative 2 is included, but in here I want to test negative 3. And let us substitute negative 3 to the value of x. We will have the quantity of negative 3 squared minus 2 multiplied by negative 3 minus 8 that is greater than or equal to 0. Thus, we will have 9 plus 6 minus 8 that is greater than or equal to 0. And we will have 7 greater than or equal to 0. Do you believe that 7 is greater than or equal to 0? Yes. Therefore, it is true. How about the second interval? From negative 2 up to 4 and negative 2 in 4 is included. Let x equals 0 and I want my testing point to be 0, and let us substitute 0 to the value of x, and we will have 0 squared minus 2 multiplied by 0 minus 8 that is greater than or equal to 0. Thus, we will have an answer negative 8 that is greater than or equal to 0. Do you believe that negative 8 is greater than or equal to 0? No. Therefore, it is false. How about the third interval? From 4 up to positive infinity and 4 is included. I want my testing point to be 5. Then let us substitute 5 from the value of x. We will have 25 minus 10 minus 8 that is greater than or equal to 0. And 7 is greater than or equal to 0. Do you believe that 7 is greater than or equal to 0? Yes, therefore it is true. Therefore, the inequality is true for any value of x in the interval from negative infinity up to 2 and 2 is included, and from 4 up to positive infinity and 4 is also included. And if we want to write it in a interval notation, we will have negative infinity up to 2 and 2 is included. That's why we use a bracket beside 2. Union 4 up to positive infinity. And we use also a bracket beside 4 because 4 is included. And that's all for this video. Thank you for watching.